So we're going to continue our discussion of the properties of functions by thinking about where a function based on its graph has a maximum or minimum value. We're going to start by thinking about what's called an absolute maximum and an absolute minimum. And the absolute means exactly what you think it means just from its English meaning. Those are points on the graph that are higher than every other point, or in the case of a minimum, lower than every other point. So I've got this graph here, and this is the one, if you watched the last lecture, this is the one we left off with. It's the time versus temperature of a mixture of alcohol and water that's being heated. And what I want to know is, where is the absolute maximum and minimum value of this function? Well, what you're looking for here is the highest and lowest points. Right? So the highest point is here, and the lowest point is here. All right, so now here the language gets a little specific. First, this point down here is 0, 0, and this point here is 6, 212. But I can only be that specific just because I know what this is a graph of, right? That's the point where the water starts to boil, and water boils at 212 degrees. Otherwise, if you looked at that and estimated 210, 205, that would be fine. So what I would say here is this function has an absolute maximum at x equals 6, and I would say that the absolute maximum is 212 degrees. Right? So when we're talking about where the maximum occurs, that's always an x value, an x coordinate. And we're talking about what that maximum is, that's the corresponding y coordinate. All right, so now how about if we're talking about the absolute minimum? Well, that's down here, right? So I would say there is an absolute minimum at x equals 0, and the absolute minimum is y equals 0. So in this case, they were the same. All right, so how about this guy? Notice the arrows, right? We're always kind of on the lookout for those. What is, and I know I said local up at the top, but let's talk about absolute first. What is the absolute maximum of this function? Well, hopefully you're thinking about that a little bit, right? This function doesn't have an absolute maximum, and it's because of those arrows, right? Any number you pick, go 1 unit to the right, and that y value is higher, right? Go 1 unit to the right of that, and to the right of that, and so on. There is no point on this graph that is higher than absolutely every other point. And you have the same problem with a minimum, right? You got the same issue here with it going down. So this function has no absolute maximum or absolute minimum. Okay, but you notice it does have a peak over here and a value over here, and those points can still be interesting, right? If you're looking for, at what point do our sales bottom out and start increasing again, then this point here is still interesting to you. All right, and these points have names. They're called local maxima and minima. And the idea behind them is a local maximum is a point that's higher than all of the points around it on either side. So if we look at this point right here, when we look at the points near it on this side and the points near it on the other side, it's higher than those points. Right? And that's enough to qualify this point as a local maximum. So I would say there's a local maximum and it is, I don't know what that point is. It's, let's call it 0.1 comma 0.6. Again, right, just like always with graphs, we're kind of estimating these numbers. And this point over here, if we look at all of the points on either side, just in kind of that narrow neighborhood, it is lower than all of those points. So I would say this function has a local minimum. That is, what do you think that is? 2.6 comma negative 0.2, somewhere around there. If you pick numbers close to that, you're fine. Now, that was a little imprecise, right? What do we mean by close to? Close is a word we try to avoid in math because it's very ambiguous. There is a formal definition of what it means. We're talking about a neighborhood and epsilons and small numbers and so forth. That's a topic for calculus, right? For our purposes, just in any little neighborhood around the point is good enough, right, to be the range that we look at to make this determination. All right, so I've got another example here, right? And I want to answer these same questions, right? And I want to answer both questions. What are the absolute maximum and minimum values, and what are the local maximum and minimum values? Okay, well, as far as the maxima are concerned, both absolute and local, there are none, right? Because this function never stops going up, right? It always gets, there's always a point higher than any point that you're going to pick. Now, it does have a minimum value, right? Because it stops here and doesn't go any lower. So I would say this function has a local minimum at the origin, and that is also an absolute minimum, right? It meets both definitions. It's lower than every other point, so it's an absolute minimum, and it is also lower than all the points kind of nearby, so it also qualifies as a local minimum. So there can be some overlap between these results. All right, so now this one is a little busier, right? And again, I want to answer the same set of questions. So actually, let me make a little table here. I'm going to do local and absolute, and I'm going to do a maximum and a minimum. All right, so let's do the absolute ones first. What point, looking at this picture, is higher than absolutely all the others? Well, I'm thinking it's going to be this guy here, right? And that point looks to be at 12, 50. And how about a minimum, right? Well, this point down here is where it kind of bottoms out, if you will. I'm going to say that is at, let's call it 7.9. It's not quite all the way to 8, comma negative 10. Maybe you call that negative 9, somewhere in that neighborhood. Okay, and that's it, right? There can be only one of each of these, right? So once you've identified that one, you're home free with the absolutes. Now, how about the locals? Well, first, remember, we kind of saw this on the last slide. The absolute extrema are also always going to be local ones. So I kind of get those for free. Right now, are there any others? Well, look at this point right here. Right, that point is higher than all of the points around it. So that point, 0, let me clear out my writing. Did that get all the way up to 40? Well, not quite. Let's call it 0, 39 is also a local maximum. Right, so with the local ones, there can be multiples. right? You can have more than one local maximum and more than one local minimum. It's only the absolute ones that are going to be unique. Okay, so there's one more attribute of a function that we're going to talk about. We've talked about increasing versus decreasing, right? And we've talked about maximum and minimums, which is really kind of where it stops increasing and decreasing and turns around and goes the other way. And in the next lecture, we're going to talk about how we can measure how fast a function is changing.